Think about the Grand Canyon, a truly massive scar on the face of our planet, carved over millions of years by the relentless flow of the Colorado River. It's a testament to the power of water and time. Many of us have stood at its edge feeling small, humbled by its sheer scale. But what if I told you that Earth's grandest canyon is just a tiny scratch compared to what we found on our neighbor Mars? Our cosmic journey begins with a sense of perspective. To understand the universe, we must be willing to see our own world as just one of many possibilities, a single note in a vast cosmic symphony. On the Red Planet, there is a canyon system so immense it defies our earthly comparisons. We call it Valles Marineris, the Mariner Valley. It was first spotted by the Mariner 9 spacecraft in 1971, a breathtaking surprise that rewrote our understanding of Martian geology. If you were to place Valles Marineris on a map of the United States, it would stretch from the coast of California all the way to New York City. It spans a distance of about 4,000 kilometers or 2,500 miles. Imagine a crack in the ground that crosses an entire continent. That's the scale we are dealing with here. The size comparison doesn't stop with its length. Earth's Grand Canyon is about 1.8 kilometers or just over a mile deep. That's impressive for sure. But parts of Valles Marineris plunge to depths of 7 kilometers or about 4 miles. It's so deep that you could stack several of Earth's Grand Canyons on top of each other inside it, and you still wouldn't reach the top. Its width is equally staggering. In some places the canyon stretches over 200 kilometers, or 120 miles from one rim to the other. You could stand on one side and not even see the other side. This isn't just a canyon, it's a planetary wound of epic proportions. So, we have a canyon that dwarfs our own. It's longer than a continent, deeper than our deepest valleys, and wider than some countries. This immediately sparks a question in our curious minds. How did such a colossal feature come to be? On Earth, the answer is usually water. Rivers carved through rock over eons, patiently sculpting the landscape, but Mars is a different world, with a different story. The forces that created Valles Marineris were far more violent, more dramatic, and tied to the very structure of the planet itself. The story of this canyon is the story of a planet groaning under immense geological stress. To understand the origin of Valles Marineris, we have to look next door. To its west lies a region called Tharsis. This is no ordinary region, it's a gigantic volcanic plateau, a bulge on the Martian surface that rises kilometers into the thin air. It is home to some of the largest volcanoes in the entire solar system, including the mighty Olympus Mons. This colossal shield volcano is so large it would cover the entire state of Arizona. The sheer weight of the Tharsis bulge and its volcanoes placed an unimaginable strain on the Martian crust. The planet's surface simply couldn't handle the pressure. It had to break. Think of it like this: if you place too much weight on a piece of thin ice, it cracks. The same thing happened on Mars, but on a planetary scale. Billions of years ago, as magma swelled up from the planet's mantle to create the Tharsis bulge, it pushed the crust upwards and outwards. The crust stretched and stretched until it tore apart, creating enormous faults and rifts. Valles Marineris is not a canyon carved by a river, it is a tectonic crack. It is the result of Mars literally ripping itself open from the strain of its own volcanic heart. This is planetary geology at its most extreme. This formation story is fundamentally different from that of our Grand Canyon. There was no single mighty river flowing for millions of years to create Valles Marineris. Instead, it was born from violence and stress. The initial cracks would have been immense, but they were just the beginning. Over time, these cracks widened. Landslides, perhaps triggered by Marsquakes, sent entire mountainsides tumbling into the chasm, broadening the canyon walls. The process was one of collapse and expansion, driven by the powerful forces churning deep within the planet. The canyon we see today is a scar left over from this ancient, turbulent period in Martian history. The great volcanoes of the Tharsis region, like Arsia Mons, Pavonis Mons, and Escreus Mons, were the engines of this transformation. As they grew, they didn't just add weight, they also pulled the crust apart. The immense upwelling of molten rock created a tension that the planet's lithosphere could not withstand. Valles Marineris is the most spectacular result of this planetary tug-of-war. It is a direct, physical manifestation of the immense geological power that once shaped the Red Planet, a silent monument to a time when Mars was a much more active and dynamic world than the cold, quiet place we see today. While tectonic forces created the initial chasm of Valles Marineris, that isn't the whole story. The canyon's incredible features suggest another powerful force was at work: water. Not in the form of a continent-spanning river like the Colorado, but in other, more subtle ways. Scientists believe that after the canyon formed, it may have held vast lakes of liquid water. Evidence for this comes from the discovery of certain minerals on the canyon floor. Minerals like sulfates, which on Earth typically form in the presence of water. These minerals tell a story of a time when parts of this great rift may have been filled with standing water. Imagine a time when the Martian climate was different, warmer, with a thicker atmosphere. Water, released from underground aquifers or from melting ice, could have pooled in the lowest points of the newly formed canyon. This water would have played a key role in shaping the landscape we see today. It would have seeped into the canyon walls, weakening the rock and making it more prone to collapse. This process, known as sapping, could have created many of the smaller tributary-like canyons that branch off from the main chasm, making the system even more complex and intricate. Furthermore, orbital probes have detected evidence of massive outflow channels that appear to originate from within Valles Marineris. These channels suggest catastrophic flood events, perhaps an underground ice dam broke, or a large lake within the canyon suddenly breached its walls, releasing a torrent of water that scoured the downstream plains. These floods would have been on a scale we can barely imagine, carrying vast amounts of sediment and rock and carving out new features in the Martian landscape in a geologically short amount of time. The ghost of this ancient water is written all over the canyon and its surroundings. So, the story of Valles Marineris becomes a two-part epic. First, the violent birth from tectonic cracking. Second, the patient and sometimes catastrophic modification by water and ice. Layered deposits on the canyon floor look remarkably similar to lakebed sediments on Earth. We see deltas where water may have flowed into a standing body of water. We see hydrated minerals that lock water molecules into their crystal structure. The canyon is not just a geological wonder, it's a potential time capsule, preserving clues about a wetter, possibly more habitable ancient Mars. Our understanding of Valles Marineris has been built, piece by piece, from data sent back across millions of miles of empty space. We haven't walked its floor or climbed its cliffs, but we have explored it with our robotic emissaries. Orbiters like NASA's Mars Reconnaissance Orbiter, or MRO, have been our eyes in the Martian sky, equipped with powerful cameras and spectrometers that can see the canyon in just stunning detail. These missions have transformed Valles Marineris from a mysterious crack into a complex and fascinating world of its own. They are, in a sense, the telescopes that allow us to journey there from our own planet. The images sent back are nothing short of breathtaking. We can see evidence of some of the largest landslides ever discovered in the solar system. Entire mountainsides have collapsed, sending debris flowing for hundreds of kilometers across the canyon floor. These images allow geologists to study the processes of erosion on Mars, where the lower gravity and thin atmosphere create different patterns than on Earth. By studying these landslides, we learn about the stability of the canyon walls and the triggers, like Marsquakes, that might have set them in motion. Every image is a new piece of the puzzle. Beyond the spectacular views, these orbiters have instruments that can analyze the composition of the rocks below. This is how we found the hydrated minerals like sulfates and clays that point to the past presence of water. These spectrometers are kind of like chemical sniffers, telling us what the ground is made of from orbit. By mapping the locations of these water-bearing minerals, scientists can pinpoint the areas that were most likely to have been wet for long periods. These are the places we would most want to visit in the search for signs of past microbial life. The orbiters have also revealed the canyon's intricate geology, showing us layers upon layers of bedrock exposed in the canyon walls. These layers are like the pages of a history book, each one recording a different chapter of Mars's past. By studying their thickness, composition, and orientation, geologists can reconstruct the planet's environmental history over billions of years. We can see periods of volcanic activity, followed by periods of sediment deposition, perhaps in ancient lakes. Valles Marineris is, honestly, a geologist's dream, offering a cross-section of Martian history that is unparalleled anywhere else on the planet. So, what comes next? While our orbiters have given us a spectacular bird's-eye view, the next great leap in our understanding of Valles Marineris will require us to go there. We need to get our boots, or more likely our rover wheels, on the ground. Future missions are being designed with this monumental challenge in mind. Imagine a new generation of robotic rovers, more advanced than anything we've sent before, capable of navigating the treacherous terrain of the canyon floor. These rovers could drill into the layered sediments, analyzing them for organic molecules, the chemical building blocks of life. The sheer cliffs and rugged landscape of Valles Marineris present a unique challenge for exploration. A wheeled rover might struggle to access the most interesting geological sites. This is where the idea of aerial exploration comes in. Imagine a fleet of autonomous drones like NASA's Ingenuity helicopter, but, bigger and more capable. These could fly through the vast chasms, mapping the canyon walls in 3 dimensions, swooping down to investigate intriguing outcrops that are inaccessible from the ground. They could act as scouts for a primary rover, identifying safe paths and high-priority scientific targets. This combination of ground and air exploration could unlock the canyon's deepest secrets. Ultimately, the grandest dream is to send humans to Valles Marineris. Picture astronauts standing on the rim of the canyon, looking out over a vista that makes our own Grand Canyon seem small. It would be one of the most profound moments in the history of exploration. Human geologists on Mars could do in days what a robot might take years to accomplish. They could interpret the complex landscape with human intuition, select the most promising samples for return to Earth, and experience the awe and wonder of this alien landscape firsthand. It is a distant dream, but it is a powerful one that drives our ambition. Why does it matter? Why should we invest so much effort to study a giant crack on another planet? Because Valles Marineris is more than just a geological feature. It is a window into the history of Mars. It holds clues about the planet's violent geological past, the story of its lost water, and just maybe the answer to one of the biggest questions of all. Are we alone? If life ever existed on Mars, the sheltered, once wet environments within Valles Marineris are one of the best places to look for its fossilized remains. Exploring this great canyon is in essence part of our cosmic search for ourselves.